Hey, what's up everybody? I'd like to welcome you to another Juice tutorial. And in this tutorial, what we're going to do is we are going to create our own oscillator class. So currently we have one oscillator that's able to play one particular type of wave, in this case a saw wave, and we can't really do much with it. So we can't do any sort of pitch changing on it outside of the input that it receives in the MIDI keyboard. We can't change the individual gain on it or anything. And now what we want to do is be able to make this oscillator our own oscillator rather than just the built-in Juice oscillator. So before we get started, just want to remind you about the audio programmer community on Discord. So we currently have over 5,000 members on our Discord, and you can join us at theaudioprogrammer.com/community. So let's go ahead and get started, and we can start by actually taking a look at what we have so far. So it's not really much to see. At the moment, we have this ADSR, and we can change the envelope of an input signal. So we currently have a saw wave, and I can change the envelope of this and make and just change the release of that. But we can't change the oscillator type, so we can't change between waves, and we can't change the gain of the oscillator or anything. And we want to change that in this tutorial. And so we're going to do this. I may need to actually break this out into a couple of tutorials, but we'll see how far we get on this one. So here we are in our synth voice class, and we have this Juice oscillator. And as we can see, we have a lambda, and we've created 3 potential different wave types that we could do that we got from the Juice template tutorial that you can find in their examples. So we have a sine wave, a saw wave, and a square wave. But we don't have any way that we can switch between these things at the moment. And what we want to do is we want to start creating that functionality and also create a couple other controls where we can actually change our wave type and do some customization to an oscillator just in case we want to create more than one. So I'm just going to go out of this into our producer. And what we'll do is we will start on the data side. So remember, we have the separation of UI and data that we want to do. I'm going to go into our data folder, and I'm going to create a new CPP and header file. So this won't be a component class. This will just be a regular CPP and header. And I will call this oscdata. And I will save it in my data folder. And there we go. We have our oscdata. Now what we need to do is a little bit of code surgery to actually take our oscillator code from our synth voice and move it down into oscillator data. So let's see if we could do that as quickly as possible. So here we are. So I'm just going to set up 2 tabs. So we have synth voice in the first tab, and then in the second tab we are going to do oscdata. And I will create a class in my oscdata folder. I will call it oscdata. And what I'm going to do is I'm actually going to inherit from the Juice oscillator class because I don't want to change the functionality of what I'm doing. I just want to add some stuff to what is already there. So that's the reason why I'm going to inherit the Juice oscillator class. But the first thing that I need to do is I need to include the Juice header so I have access to all of my Juice functions. So that's why I'm going to put this here, include the Juice header. And now what I could say is that oscdata is going to inherit from Juice, DSP, oscillator. And because oscillator is a template class, I need to actually specify what sort of input type that I want to give it. So in this case, I want to give it a float. And now I do this, and we will set up public and private areas for this. And now what we're going to do is we need to start deciding what type of functions that we're going to need for this oscillator class. So we need to actually pipe in some of the things that we're already doing in our current oscillator. So one of the first things that we're going to need to do is be able to select our wave type, right? So let's go ahead and do that. So first thing that I will do is go back into, I have a bad habit of doing this, changing them to the same thing. So one thing that we'll do is we'll set up a function. We will call this void set wave type. I'm just going to leave the input blank for now, but we will need to change that later. Okay, and we're just going to start off with basics and just build up as we require new information. Okay, so we got void, and then this is osc data set wave type. And now what we could do is we go to our synth voice class, and what we want to do is we will just grab this information for our sine wave, saw wave, and square wave, and we will pull this in. Okay, so we will just set this here. And so now we just need something that selects between the sine wave, the saw wave, and the square wave. So if you were doing this, what sort of data structure would you use, or what sort of logic would you use to actually select the type? To me, a logical choice here would be a switch statement, because you can switch between different types, right? So that's what we're going to do here. So what we'll do is we will call a switch statement, and now you see that we're in a situation where we need some sort of input, and normally the input has to be either an enum or it needs to be an int into a switch statement. Okay, so because of that, now we need to ask ourselves, okay, well, where is that going to come from, right? We're going to need to have some sort of input that's going to be able to read what the selector actually chooses. So because of that, I'm going to create a const int choice variable here, and then I will put choice in the switch statement here. And because of that, I need to put this in set wave type in my header as well. And there we go. So now that error should go away eventually. So now we could say, okay, based on the choice, it's going to select our wave type. So we could say choice 0 will be the sine wave, choice 1. So we have case 1. And then we will need that to be our saw wave. Make sure you put a break afterwards as well. And then case 2 will be our square wave. Break. Then what we could do is we could do in the default, I will put a jassert false. Okay, which means that if I come to this point, this means that case 0, 1, and 2 did not work, which means that something probably went wrong. And I will do this jassert false, which will actually pause our plugin's execution and basically say, hey, you're not supposed to be here. So we know something went wrong if we get into line 34. Okay, so now we need to actually set the wave type. Okay, so here we go. So let's just go to our Juce API. By the way, I will put the link to the actual synth in the description in below the video. So we need to go into our oscillator class, okay, because this is a Juce oscillator, and we see that we have this initialize function where this can take a stood function or a lambda that will tell us what type of wave that we want it to be, right? So because this is a Juce oscillator float, we're inheriting from Juce oscillator. What I could do is I could just say initialize, like that. And then what I'll do is I will go back to my synth voice class. I will grab all of this code now. bring it in here. Now that's the saw wave, so what I need to do is I just need to paste this in. Don't worry, we will actually fix all of this. So I always get these messed up. So it's like that, right? Yep, great. So now that's our sine wave, and here we can actually just leave a little comment. And then we got saw wave, just copied that from above, and now we're going to return our saw wave, and this needs to be, this is a juice function, so we need to have juice preceding that. And then same thing for our square wave. So here we go. And I will just take this and I will paste it into here. So now we have a sine, a saw, and a square wave that we could switch between. Right? I could just erase this. So there we go. So now we need something where we can actually make a choice, right? So where would we actually do that at? Sensible place that I would think to be able to do that would be in our audio processor value tree state, because that's going to list all of the parameters that we're able to control in this synthesizer. We want the user to be able to control the wave type. So that's why we're going to go into our plugin processor all the way down to our audio processor value tree state and create a audio parameter choice parameter that the user is going to be able to use to select the wave type. So once again, we're adding a audio parameter in here. So it's going to be stood, make unique, and then this is Juice. And if we go into our Juice API here, and then we could go into audio parameter. As you can see, we have a couple different ones. We have audio parameter bool, which would be a true or false. Don't want that, right? We need something that chooses in between the different wave types. So that's why we would choose audio parameter choice. And now we got this long piece of code that we need to put in, but it's okay. We will just work through these one by one. So we got Juice, audio parameter choice. Now we got all of this business to put in. So we got the param ID. So this will be OSC1 wave type. And then we have the parameter name. So OSC1 wave type. Now we have this const string array and choices, right? Now, how do you do that? If you're not sure, just go back to the API and just have a look, right? So we could just go in here, we can actually click into string array, see how it works. So a string array is just a special array that holds strings. And you can initialize it with the first value and all of the other values that you want, right? So it just contains strings. So that's not too bad. So what I could do is I could just initialize it in line by saying Juice string array. And now I'm going to make the choices. Once again, they're strings, so I need to do this. So we have our three choices. We have sine, saw, square. That's it. And then we have our default item index. I always forget if this needs to be 0 or 1. I'm going to make it 0 for now, which would, I think, would make it sine, but I can't remember whether the default has to be 1 or not. And then the parameter label, so we don't need any sort of label for this, doesn't need to be hertz or anything like that, so I could just leave that blank. And then these last two, just for simplicity's sake, I will just leave these off, and they will be, because they're optional arguments and we don't need those. I think actually this last one is optional as well, so we will try that. So I'm just going to try to build here. I'm going to build this in standalone actually, just to make things a little bit quicker. So we will see if I actually did that properly. Okay, so we've now done that properly, so no problems. So now we need to connect this into Oscdata, right? So we have a few problems. First of all, our plugin processor doesn't have access to Oscdata at the moment. So how are we going to do that? So one option is that we could have the oscillator running through Synth Voice and then into plugin processor. So Synth Voice has access to the oscillator and runs into plugin processor, right? So that seems sensible because each Synth Voice is going to have an instance of this oscillator, right? So it wouldn't make sense to try to give the plugin processor direct access to our Oscdata class, because it needs to be able to switch the wave type for each instance of our oscillator, which is going to be residing in Synth Voice. So for that reason, what we need to do is we need to be able to give access to either the whole Oscdata class or to this single function set wave type. In this particular situation, I might just give access to the entire Oscdata class. Okay, so let's look at how we're going to do that. So first of all, our Synth Voice has to know about Oscdata. So Oscdata at the moment isn't going anywhere. It's just a class that we've created. So we need to actually replace our oscillator in Synth Voice with the default oscillator that we have residing in Synth Voice with our oscillator class. So what we'll do is we will include that class now. So we include data and Oscdata. And then what we'll do is we will create an instance of our own class, which is Oscdata, right? And we will call this Osc. Now, what I'm going to do is I'm just going to comment out the default oscillator class that we have. That should work, right? Because the thing is that our oscillator, Oscdata, inherits from Juce Oscillator. So because of that, everything that was previously working in our Oscdata, in our Synth Voice class, should also work for our Oscdata instance, right? So everywhere that we're calling our oscillator, oscillator.prepare, oscillator.process, all of that should be fine because our Oscdata inherits from Juce Oscillator. So now going back to our original problem though, which is that we need to somehow give our plugin processor, which is almost like our parent class. So think of that as like the brain of the plugin, right? That's the top level. And so now what we need to do is we somehow need to give our oscillator its access to the wave selection that we've made, right? So what we will do is we will go into our synth voice class. And what we could do is we could say, we will do, so this is going to be an instance of Oscdata. We will make this a reference because we don't need to make a copy of our oscillator. We just want to reference the oscillator that actually exists. So we will say, we'll create a method called getOscillator. Since this is a one-line function, I will just keep this in the header. So one-line functions, everybody has their own rules. My rule is one-line functions are okay in the header. Anything that takes more than one line, put it in the CPP. So getOscillator, and what we can do is we can return our oscillator, right? Our oscillator object that we've created right here. Now what I could do, because I've given access to that, now I can go into plugin processor, and then we have our audio callback here where we're actually updating our parameters. And what I can say is I can do another parameter here where we say auto reference osc wave equals, and then we need to go into our audio processor value tree state, get raw parameter value, and the name of our raw parameter is osc1 wave type. Okay, just put this in quotes, so this is a string. And how do you suppose that we will call this method now? How do we get access to the oscillator? We will do voice, right? So we need our synth voice. Get oscillator. And then dot, so we get our oscillator, and then we do select wave type. And now we could put our osc wave, I'll call it osc wave choice, so I'm just going to rename this. Okay, so there we go. So now let's just build this, see if this works. So we won't see a selector, right? Because we haven't created a selector component, but we will. Okay, so that's fine, right? Because this audio parameter choice is starting from 0. So we got 0, 1, 2, and in our oscdata.cpp, we have it coming in, and then we have this choice 0, 1, 2. Okay, sine, sol, square. So that should be fine. So now what we need to do is we need to create a component for this, right? So we need a place where the user can actually select what wave type that they want. So we will go out of this, back to our producer, and we need to go into our UI. And in here, we will do a new component class, and this component class will be called osc component. Right? Make sure you make it a component class, because this is a Juce component, which is going to be a visual class, right? So this is going to be a visual component that the user sees. Now we can open this back up in the producer, and here we go, and then back into our UI, into osc component, and now we're in osc component. So now we need to have a selector. So in this one, I'm going to use our combo box class. So we have a class called combo box. And here it is. So here we go. So now I can just call this by saying Juce combo box. I'll call this Osc Wave Selector. And then we also need something that is going to attach to our audio processor value tree state. So we will need to create a stud unique pointer, and you have these attachments, right? So just duplicating this again, going back to our API. So we have this, for sliders, we have a slider attachment, and for the combo boxes, we have a combo box attachment. So here we go. So it's not too bad. It's a little bit of code, but it's okay. So we got Juce audio processor value tree state combo box attachment. I'll just call this OSC wave selector attachment. Okay. Now we will go into our constructor. Now we need to set up some options for this, right? So let's have a look back at our combo box class, and we need to figure out how to give it some choices, right? So we need to tell the combo box what we want to, the strings that we want to be displayed in the combo box. So we have this handy function called add item list, and this takes a string array. So we created a string array before, and that's how we do it here. So I could say auto wave choices, or actually I'll do it like this. So sorry, Juce string array choices, and then here I could say sine sol square, and now I can say OSC wave selector add item list. So then in here I will just say choices. This, I think it has to be 1. I always get this mixed up, so I'm just going to try 1 here for now. And of course we need to add and make it visible because it's a visual component, and we will say OSC wave selector, and we need to do our combo box attachment, right? So we got OSC wave selector attachment. Since it's a unique pointer, we need to allocate the memory using make unique. And then this is once again Juce audio processor value tree state combo box attachment. And now we just need to figure out what arguments we need to actually initialize this. So we need the audio processor value tree state, state to use, the parameter ID, and the combo box. Okay, so now we have another problem, right? So we don't have any access to the audio processor value tree state where we are. How are we going to get that? We don't have access to the parameter ID either, do we? So let's have a look at where we want to use this. So we want the oscillator component to be in our editor eventually. So here we are. So let's see. Not sure why this is here. Maybe I started doing that and then stopped, but I'm just gonna delete that. And I will include UI/OS component header file. So let me make sure there's nothing else kind of hanging around. So I must have started doing that before I actually did this tutorial. Okay, so here we are. So we have our OSC component now that's visible to our plugin editor. And now we can initialize it by saying OSC component. I'll just call this OSC. And now what we need to do is figure out how we're going to give access to the actual oscillator, right? So the best way for us to do this is in our ADSR, in our initializer list, right? So what I could do is I could say, since this is coming before ADSR component, it needs to be before ADSR in our initializer list. So I will initialize it like this. Sorry, after the comma, OSC, and then what we need to do is we need to give access in here to certain pieces of data, right? So the first thing that we need is, going back to our documentation, sorry, I'm getting a little bit mixed up here. So we have audio processor value tree state. Okay, so we can pipe that through the editor because we have access to the audio processor reference, the audio processor value tree state. And what I could do is I could just pop that in here, right? And what that does is that says that in the constructor, I'm taking the audio processor value tree state, I'm piping it through into the oscillator component class. So now what I need to do is I need to make that a argument in the constructor. So I will say Juce audio processor value tree state. Needs to be a reference. We don't want to make a copy of the audio processor value tree state. So that's why I'm going to put the ampersand, and I'll just call this APVTS. And then we need to do that in our CPP as well. So here we go. Now, why did we do that? The reason we did that is because our combo box attachment needs access to our audio processor value tree state. That's the first argument in our combo box attachment, right? So now we have that, APVTS. So that's the first argument. Now we need the second argument, which is the parameter ID of the combo box, right? So once again, we go back to the plugin processor, which is kind of our brain for our plugin, and we have the parameter ID within the audio processor value tree state, which is OSC1 wave type. I'm just going to copy that, and then in here I will just pop it in here like this, OSC1 wave type, and then in the OSC component class, now I just need to update my constructor. So I will say Juce string wave selector ID. And then what I could do is I will just pop that in here. Now I have my second argument. I need to make sure I update the header file as well. So quite a bit of updating that we need to do. And then going back here, we have wave selector ID. And then the third argument is just the combo box that we're trying to attach it to, which is, of course, OSC wave selector, like that. Okay, so this is what this selector attachment is, what enables you to sync up and connect the choice that the user makes with the actual visual representation that they see. Okay, so that's what that's doing. That's connecting what basically the front end, what the user sees, to the back end, which is the plug-in processor where the data actually happens. So the behavior is that the user makes a choice. So they change the choice in the combo box. That signals to the audio processor value tree state, hey, the user has made a change. And then in the audio callback, it says, hey, the user made a change. And then that goes into the data, the oscillator data class. And it selects the wave type, which of course in osc_data selects the wave type there. Okay, so that's how that happens. So it's a little bit of, it's a three-way kind of communication that's happening. Front end UI, plug-in processor, and then the oscillator class. Okay, so now we've done that, and here in this paint, I will just get rid of all of this. I will fill all with black, color black, and then in resized, so let's just, I have no idea how big I want to make this, so let's just say that Osc selector, wave selector, set bounds. So we'll just do some static X and Y positions for now. So let's just say we want it to be 0, 0. So it starts at the origin. We'll make the width of this, let's make it 90, and the height of it, let's make it 20 pixels tall, right? And then what we could do is we could just make the, now we have to set that in the plugin editor, right? So what I need to do is go back to the plugin editor. This should clean up. Actually, I'm just going to build this very quickly. Just make sure we don't have any errors. Okay, cool. So we got build succeeded. And now what we need to do is we need to make our oscillator visible, right? So I need to do add and make visible osc. And in here, I will just set it up just kind of anywhere, really. Just try to get it on the screen, see if it actually works. So we got set bounds. So let's just do 10, 10, and then since our oscillator component is 90 and 20, I'll just make it a little bit bigger. So I will make it 130. And now we'll just build to see if it actually shows up on the screen. So it should. Okay, there we are. So now we have sine, sol, and square. And we see that when we've selected those, it hasn't actually broken the plugin, which is nice. Okay, so we haven't gotten any crashes. We haven't tested it out properly yet, but we want to do a couple other things before we actually test it out. So let's go back. So I think we're okay now for the OSC component for the time being. So let's go to OSC data. Now what we want to do is we want to have, what I like to do is, now that I have this oscillator, this kind of custom oscillator class that I've inherited from the Juce oscillator, I don't want some of that behavior to be living in OSC data and some of that behavior to be living in synth voice, right? So what I want is, I want all of this now to be called from the OSC data class. So what I'm going to do is I'm going to wrap all of this kind of behavior that we've done and wrap it in the OSC class. And the reason that I'm doing that is because at a later point I might want to start adding other things into into this class, right? So first thing I'm going to do is I'm going to take this osc.prepare, and I'm just going to create a method. I'm going to call it prepare to play. And let's see, what does this need to take? It needs to take a Juce process spec. So this is more kind of future-proofing for stuff that we're going to do a little bit later when we actually add some more complexity to this osc data class. So we will do void osc data prepare to play, and then in here I will now just call prepare. Since we're already in the class of the object, I just need to call prepare. I don't need to call osc.prepare. And now I will replace this with osc.prepare to play and put the spec in there like that. Okay, so that's fine. Now we have this osc.process that takes a audio block. So I'm going to once again create my own function in here. So I'm going to call this void osc data. I'll just call this get next audio block. And like I said, at the moment, probably doesn't really make a lot of sense why I'm doing this, but I promise that as we go into future tutorials, this will make much more sense. So this will take a Juce DSP audio block argument. So I will make this a reference to our audio block. And then once again, I will take this, I will cut it out, and I will come back to that in just a moment. And now I can just call process, and this has to be changed to block. Okay, and now I need to actually add this to my header now. There we go, boom. And now here I need to call osc.get next audio block, and in here I will put audio block. Okay, like I said, doesn't make much of a difference at the very moment. Okay, just need to have a look at anything else. So we have this one other method called SetFrequency. Okay, so let's do that in here as well. So we will call that right here. So I will call this void. Let's see. What shall we call this? Set wave frequency. So it can't be the same name as what it's called currently, because if it is, then it'll be talking about the parent method, unless you override it and you create the whole thing yourself, which we don't want to do. So in here, now I want to call set frequency. So I'm just going to once again cut this out of here. Sorry, I'm going to go to the, so in here I need to, let's see, what is this called? Juce mini message. So this takes a Juce MIDI message, right? Get note in hertz, or MIDI note number. So this will be const int MIDI note number, and then set wave frequency. So I will call that here, void osc data set wave frequency. Okay, and then once again, since I'm already in my oscillator class, I can get rid of this osc.setFrequency. And then I just go back to synth voice. And once again, I call osc.setWaveFrequency. And then in here, I put MIDI note number. Okay. So that should be working fine now. Okay. So now let's try to build this actually in Ableton and test it out and see if this actually works. I think that'll be a good place for us to conclude our tutorial. So once we finish doing this, so now we will pull in so here we have our, I'm just going to make sure that I have the sound routing right. So here we go, just turn your headphones down just a little bit just in case you have it up loud. So we have sine wave, that's working as planned, saw wave. So there we go. We see now we have a selector. So that's working as planned. I think that's a good place for us to conclude the tutorial today. So that was quite a bit longer than what I anticipated. As I said before, the main reason that we're subclassing oscillator out is because what we want, the data class, the main reason we're doing that is, what if we wanted to add a pitch parameter in set wave frequency, right? If we wanted to do that, the best place for us to do that would be here in the OSC data class, right? If we didn't actually take this and start wrapping these methods in the class that we're in, then what would happen is that we would need to go in the synth voice class, and we would actually be trying to implement that behavior in this class, and that doesn't really make sense, does it? It makes sense to have everything encapsulated within the oscillator itself. So that's the reason why we're doing that. So that's where we're going to end it, and I hope you enjoyed this tutorial. If you enjoyed it, be sure to give a like and subscribe if you're not already subscribed, and we will see you next time.